this lesson is on least common multiples, and you learned how to find least common multiples way back in lower school, where you just listed, say, the multiples of 6, 12, 18, 24, and then you listed the multiples of 21, 21, 42, 63, and you found the smallest one that they had in common. I'm going to teach you a different method, sometimes called the cake method, and we're going to use it with polynomials. So let's start with 6 and 21. When you have 6 and 21, you start by writing them down, and then you draw what looks like an upside down division bar right there, and then you look for what factors they have in common. 6 and 21 have a factor of 3 in common, so we write that on the outside. 3 goes into 6 twice, it goes into 21 7 times, and then we look at that 2 and 7 and say, do they have any factors in common? Since they don't, that means we're finished. And what we're going to do is we're going to circle right along this L. Least common multiple, you're looking at the whole L. 3 times 2 is 6, times 7 is 42, and 42 is the least common multiple for 6 and 21. Obviously, if you're dealing with whole numbers, this method is not the best method, but it's going to work for what we're going to do in a little bit. So if we have 3 numbers, 8, 10, and 20, it works a little bit differently, and the number that you use only has to go into at least 2 of them. So if you notice 10 and 20 have a common factor of 10, you can write that on the outside, but since 10 is not a factor of 8, we're just going to write down the 8. 10 times what gives us 10? 1. And 10 times what gives us 20? 2. Now we look at our 3 numbers and say, is there anything that is a factor of both 8 and 2? And 2 is a factor of 8 and 2, so we're going to put that on the outside. 8 divided by 2 is 4. We're going to just bring down that 1, and 2 goes into 2 once. And now we're done, because 1, 4, and 4 don't have any, 1, 1, and 4 don't have any factors in common except for 1. So we're going to multiply all the numbers along our L. 10 times 2 is 20, times 4 is 80, times 1 times 1. 80 is the least common multiple for 8, 10, and 20. So what happens if we have something like 21 and 4? Why is this one a little bit different? When you look at it, do they have any factors in common? They don't. So all you're going to do is multiply them. And 84 is your least common multiple for 4 and 21. Okay, so now when we get into monomials, what do? We write them down again, 4x squared and 10x, just as we did before, and we're still looking for common factors. What do 4x squared and 10x have in common? They have a 2x in common. So 4x squared divided by 2x is 2x. 10x divided by 2x is 5. Because 2x and 5 don't have any factors in common, we have our least common multiple right here. 2 times 2 times 5 is 20, and x times x is x squared. So 20x squared is your least common multiple. Here we have 24x cubed and 20x squared. We're going to repeat that same process. Because these are monomials, we can see their factors. We don't have to factor them the way we do binomials and trinomials. We know the factors of 24 and 20. Their greatest common factor is 4. Greatest common factor for x cubed and x squared is x squared. Because remember, x cubed is x times x times x. X squared is x times x. So they have an x squared in common. So 24x cubed divided by 4x squared is 6x. And 20x squared divided by 4x is 5. Since 6x and 5 don't have any factors in common, we're ready to multiply here. If you do 4 times 6 is 24, and then you need to multiply it times 5. Or you can remember that you can multiply in any order. We can work the other way. 5 times 6 is 30, times 4 is 120. That was a little easier for me to do in my head, so you get to choose. X times x squared is x cubed. Oops, let's rewrite that. 120x cubed is going to be your least common multiple. Now we get into having a mixture of monomials and binomials, If it's a monomial, we can't factor it. We can see its factors, so we just write down our x squared. But x squared plus 2x does factor. It has a greatest common factor of x. So we're going to factor that out and write down the factored form here. Then we want to look for what do they have in common. Well, we can only look at monomials with monomials and binomials with binomials. So what do x squared and x have in common? They have an x. If we take that out, we're left with x. Over here, we're left with x plus 2. That's all we can do because x and x plus 2 don't have any factors in common. So when we multiply along here, we have x times x is x squared times x plus 2. So x squared times x plus 2. All right, here these are a little bit longer problems. That just means there's a little more factoring you're going to need to do. X squared minus 9 factors to x plus 3 times x minus 3. Then we're going to factor x squared plus 5x minus 24. So we need factors of 24 that add to give us, of negative 24, that add to give us positive 5. 1 and 24, 2 and 12, 3 and 8. That's going to work. We want negative 3 and positive 8 in order to give us that positive 5. So we have x minus 3 and x plus 8. Now you want to compare your binomials. Do they have any binomials in common? They both have that x minus 3, so we'll take that out here as a common factor, leaving us with x plus 3 and x plus 8. X plus 3 and x plus 8 don't have any factors in common, so your least common multiple is this long mess of x minus 3 times x plus 3 times x plus 8. That's it.